Alright, so this question is saying that we have two ships, S and R, are on a lake, and FT is a vertical tower. Right? So we have FT here as a vertical tower, and the two ships on a lake. They want us to find what is the length RT from here to here, and what's the height of the tower, and what's the length of ST. Now, you might be thinking, since you probably might be new to this, what laws can you use to solve this problem? And there are different laws. So you might be thinking, okay, should I use the sine rule, which states that A over sine A is equal to B over sine B, which is equal to C over sine C. Now these are small letters. Now these would be the opposite, this would be the side, and this would be the opposite angle to the side, okay, for every corresponding one. Or should we use the cosine rule, which says that A squared equals to B squared plus C squared minus 2BC cosine A. Now that's the angle that is related to A, right? As we have seen on top here. Or sometimes we have this rule called, that I say SOHCAHTOA, which is the sine equal to the opposite over the hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over hypotenuse. Now that has to do with a right angle triangle. Okay, note it has to do with a right angle triangle. Okay, so which rule are we going to use? The reason why we can't use the cosine rule is because there needs to be two known sides. In this simple triangle that we have here, or even in this entire right angle triangle, we know only one side, and that's the value of 150 for this triangle. It's a good thing that we also were provided with two angles, 18 and 22. So we could easily say that a triangle adds up to 180 degrees. So 180 minus 18 plus 22 would be 140. Or this angle is a straight line, so it will be equal to 180. So 180 minus 40 would be 140, right? Okay, so we are going to calculate this. So basically we're going to use the sine rule, right? So the sine rule that I would use, I would say it like this. Sine B. Now in this case, let us call A RT. And let us call, so this is RT, this is what we're trying to find, right? We're trying to find this. So the angle opposite to this side would be 140. So we're going to say sine 140. Now for you who's just learning, I'm just saying that A in this case is RT, and this sine A, which is also the angle related to RT, is 140, right? Is equal to B. What would be your B? B would be 150, because that's the only side we know, right? So 150 meters over sine, which angle is opposite to B? This one, right? So it's 18 degrees, right? So sine 18 degrees. So let's go on and make RT the subject of the formula. To do so, we would have to multiply by the reciprocal. So I would multiply this by sine 140. And these two are going to cancel each other, and we're going to have sine 140 here. And this answer. So now that we have RT is equal to 150 meters over, when we convert it in our calculator, we're going to get 0.3090. I always like to go to 4 decimal places. Multiply by sine 140 would be something like 0.6428. And so that would give us an answer of 312.04 meters, which is essentially the same as just saying that RT is equal to 312. Okay, good. Now, since that we know that RT is equal to 312, the other question is we have to find, so the answer was 312 meters. We have to find what was the height of FT. Now FT is the nice tower that we have here. And in this tower, you notice there's a right angle triangle making the relationship with this boat here. Or even here, there's a right angle triangle. Now we know what is the side, what is the value of this side, the length of this side, but we do not know the other values of that triangle. So let us say we was to take this triangle. In our minds, I want it to look like this, right? R, F, T. And so we have 3, 12 here. And this would be a right angle triangle. Okay, we don't know what is this side, and we do not know what is the height here, right? So we know what is the angle right here, which is 22 degrees, right? Now, should we use sine, cosine, or SOHCAHTOA? Let's hint. So, alright, so should we use sine, cosine, or SOHCAHTOA? Now, can we use sine? Do we have the ability to use sine? I think we can use the sine rule. Okay, we can use the sine rule. So we could also use the SOHCAHTOA rule, which may be shorter, but let's try and use the sine rule first. Okay, so we're going to use the sine rule. So let's say that we're trying to find FT. Okay, the angle opposite to FT over here would be, this would be the 22 degrees, right? You notice, right? Can you see it? Excellent. So it'll be sine 22 degrees is equal to, do we know another side of this triangle? 312 over sine, what is the angle opposite to it? 90 degrees, right? So this is 90 degrees. Sine 90 degrees. And we all know what sine 90 degrees is. Well, so let us say we want ft to be the subject of the formula. So we'd multiply by the reciprocal by sine 22. This will cancel on this side. Sine 22. And we will find that ft is equal to 312 meters over sine 90 is actually 1. Multiply by sine 22. Let us see what is sine 22. It'll be 0.3746. 0.3746. And this will give us our answer, which is, so this will be, it's basically 312 times 0.3746, which is 116.875, which we could probably round off and say it's 116.9 meters, right? Now, the question is, isn't this kind of the same thing as probably using one of the signs, SOHCAHTOA? Yes, that is exactly so. We may arrive at the same scene where we have to multiply 312 by 0.746, or let us just see, okay? So we got that the height of this is 116.9 meters. Let's see how it is using the sine rule. So let's just erase, not the sine rule, but the, should we use the SOHCAHTOA stuff that I'm talking about? So we have, okay, so if we know what is 312, which is the hypotenuse, we need to know this would be the opposite, because it will be opposite the angle here, which is 22, right? This here, this would be the opposite side, because it is opposite to the angle, and this would be the hypotenuse. So which one are we going to use? We're going to use so we would say that sine 22 degrees is equal to the opposite, which is, we do not know, ft, over the hypotenuse, which is 312. Now, as you can see, we need to make ft the subject of the formula, so we multiply by 312 meters on both sides. And this will give us something like, well, ft would be on the other side, but it's essentially the same. So sine 312 times sine 22 would be 312 times 0.3746 is equal to ft, which is 116.9, which is equal to ft. So it's the same answer. Alright, and so the last question asks us, what is the length of ST? So we want to find the length of ST. So we now know that this side is 116. Alright, so we were to find what is ST. So if we notice, ST is also another right angle triangle. It's another right angle triangle that I'm going to attempt to draw here. Oops. Oh my god. This is SFT. We know that this side is 116.9 and we do not know what is ST. And this angle here is 40 degrees, as we have seen over here, right? So, what can we use? This is actually, it's asking us to find what is the hypotenuse. So should we go back to our SOHCAHTOA? Because we already know what is the opposite, we already know what is the angle, and we need to just find one more side. Yes, we should go back to our SOHCAHTOA. So, we would have sine 40 degrees is equal to the opposite, which is 116.9 meters, divided by ST. Now, something that we could do in mathematics is I would basically switch the sides. So I'm going to say I need to find what is ST. So I'm going to put ST here. I'm going to put sine 40 under here. Another way to do it is by going slowly and multiplying ST by ST on that side, the reciprocal, and doing the same thing on that side, and then also multiplying sine 40 by the reciprocal on that side and on that side. But the faster route is to just say swap. So it's going to be ST is equal to 116.9 divided by sine 40. Sine 40 is 0.6428. And that would be equal to 181.86. 181.86. Okay, meters. This would be the answer for ST. Alright, as you can notice, it would be, let's say 181.9. It would actually be a shorter length than the 312 that we got. And obviously, because this ship is closer to the building, so whenever you get your answers, you need to make sense out of your answers. Okay? Alright, so some may say, why didn't I use the cosine rule? And the cosine rule is much longer. I could have used the sine rule, using like the one I just used, to find what was ST, which would be a faster route. However, if you notice, like I've said before, that we needed two known sides to use the cosine rule and an angle to the side that you want to find to use the cosine rule. So we could actually have used the cosine rule if we did not know what was ST. So in our minds, it would be something like this. The triangle would look like this. Note, it's not a right angle triangle. And we know that this side was 312, and we know this side was 150, and we didn't know what was ST. And we know the angle here, which is the opposite angle to ST, it would be 22 degrees. So our ST would actually be our A squared, right? So we'd have like a A squared equal B squared plus C squared minus 2BC cosine A. Right? So our A squared would actually be our ST. So that would be something like ST is equal to B squared. Let's call any 150 or the 312B squared. 150 squared plus 312 squared minus 2 times 150 times, okay, let's do this somewhere else. So let's say ST equal to 150 squared plus 312 squared minus 2 times 150 times B, sorry, times, it's late in the night, I'm sleepy, times 312 multiply by cosine A, which would be the cosine, the angle related to ST, which would be 22 degrees, right? 22 degrees. I solved it, so I think cosine 22 degrees would be something like Yeah, that would be something like 90.9272. And when you find all of this, it's actually st squared, sorry, st squared. When you find all of this, you're going to say that st is the square root of all of this. I'm not going to solve it, but I know that the answer that you're going to get is going to be equal to the answer that you're going to get is going to be equal to the same 181.9 meters. Now, if you notice how long it took for me to get that answer in comparison to if you viewed the triangle as a right angle triangle with F and S and T, and knowing what was FT, which was 116, and knowing this angle here was 40 degrees, using this SOH method, then you understand that this was much faster than finding the using the cosine rule. However, sometimes, well, a lot of times, you're not going to be presented with a right angle triangle. So whenever doing a right angle triangle, it is best to probably, and you only know one side and the other angles, it's best to do the SOHCAHTOA rule. If you know two sides, then you could probably use the Pythagoras theorem, which I did not state, but Pythagoras theorem is a squared is equal to b squared plus c squared. So you could have, but whenever you have this type of triangles and you have two known sides and an angle, it's best to use the cosine rule. Sometimes you can even still use the sine rule, but it may be best sometimes to use the cosine rule. Okay, thank you.